Hi everyone, my name is Anvita Bansal and I am back today with another lecture based on backtracking. So the problem that we are going to discuss today will be word boggle. So let's move to the SD sheet and let's see the problem statement. So this is the question we are solving today. Let me check if you guys are able to works. Okay. So what are you given in this question? You are given a dictionary of some words and you are given a grid called as board here. So this grid contains some letters as you might relate it with crossword puzzle, remember? So what kind of a board you have? You have a board with certain letters, okay? And here you in this board each place is occupied with some letter. You need to find if what all words from the dictionary you are able to find in the board and in what directions you can go. I'll just explain that question to you, that thing to you. So the question typically says that you have to return a string array which contains words from the dictionary that you can find in the board, all the words. So if you see in this test case, this is your given board and these are some words from the dictionary. So what all words you can find in the board that you have to return, okay? So let me just show you one question, just a second. Okay, let me just take one example here, a test case. Let's say that you are given a dictionary. Your dictionary is given with words that are BCD and BD, okay, DB, let's say. And there's one board. The board is given like this. Let's say this is your board. You have D, D, B, F, okay, E, C, B, C, and D, C. Let's say this is the given board. Okay, I'll take the example from the first test case also, but that's just one word, so wouldn't be a very good example. Okay, so if I take this one, this is the board that you are given. This is the dictionary. You have to check if what all words from dictionary are you able to find in the board. So the directions in which you can traverse will be 8 directions, and those directions are basically you can move along the column, you can move along the row, you can move along the diagonals, right? So that's your movement. So let's check any word if we are able to find it. This is B. I found one B. Then B, C. If I diagonally find C here, I can go in this direction. From C, I can find D here, but this is not allowed to go. I can go only one column, one row, and one diagonal in my movement. I cannot skip or I cannot move more than one unit. Okay, only one unit of movement is allowed at a time. So obviously this B is not going to give me BCD. Let me check from this B. If I travel to this C, okay, and from this C, if I travel to this D, I can find BCD. Is there any other possibility? If I go from this B to this C and back to this D, then also I can find it. So I just have to check if I can find a word. If your dictionary contains that word only once, your final answer should also have that word only once. No matter that your board, in your board you can find it 2 times, right, as I just showed you, but you have to return it only once if your dictionary has this word only once. Fine. So let's check for DB. If I travel from D in downwards direction, one step down to it, I'll get DB also. So my return arrow will contain BCD and DB. Let's take the first example. So in this example, let's take this one only. You have GIS UEK. Let me write the board. So your board looks like this. You have K. Let me check what is next. And then you have QSE. And the words that you are given to find in your dictionary or in your board that are given in your dictionary are geeks, right? All capital. So don't confuse. For there is other word quiz, okay, and there is other word go. So let's see what all words can I find in this board if I take the words. Let's see if I can find geeks. So G, I start from here, I can go diagonally in this direction. From E, I can go here diagonally downwards. Then I can go one step up right? From K I can go diagonally to the left direction, downwards diagonally. So this is how I can find geeks. So I will return geeks as one of the words. Let's see if I can find for. There is no F only in this board, so there is no for. Let's see if I can find quiz. So this is your Q. Go upwards, go diagonal, go right. You can find quiz. Let's check if I can find a word go. G is there. But see one more thing, that if G is already consumed in other word, you cannot use it for go again. Let's say for example you had GO also. So you cannot return GO because geeks has already, this G has already been used for geeks. Either you return go or you return geeks. That's what you should do. Okay, so let me see what they're saying. A cell can be used only once in a word. So if you find this in your question, a cell can be used only once in one word. So this is the difference that I wanted to show. If there was an O here, you would have either returned go or geeks, not both. That's what you want to return. Okay, so moving to the approach, what we can do. So approach, you already can see it quite evidently. For either one thing that I can do, the one thing I can do is, you have the board. Okay, from board you check at every place, you find a word, you find a letter, you try to check if there is any word in the dictionary starting from that letter. If it is, one second, if you find such a word starting with that letter in your dictionary, you go and traverse over all the possible directions if you are able to find the exact word that your dictionary contains. If not, then you check for the next, one, next position. If you are able to find a letter which your dictionary contains, in short, you traverse over the entire grid, check for each place, you apply recursion, which is typically backtracking here. I'll tell you why when we will discuss the approach. So the approach says that you are, for every position, you are applying recursion in all the 8 directions, right? In all the 8 directions you are checking. And then while applying this recursion, you are keeping a track of what string you are able to find out by moving different places. If the string matches any of the word that your dictionary contains, if it matches with any of the word that your dictionary contains, then you will add this string to some answer array, right? Answer array. And if not, then you move to the next position in your board, in whichever direction you are moving. You go to the next direction, you check if you can find a word starting with D. Okay, so let's say this was D. So what you did in this approach, that you explored all the options. From D you can go towards right, that is J plus 1. From D, if you move to right, you find a D and there is no word which has D, right? So you backtrack, you see if you go, you can go in the downwards direction. Yes, there is DB. You eventually found a word which is present in dictionary, so you will return this word, you will add this word into your answer. Now what? Now you move to the next position in your, so with this D you will also mark it visited, that you have already found a word. Now you will move to the next position in your grid. This is this D. Now can you find a word with starting with D, but you have already used that word which started with D, so you will also have to make sure that you do not visit the same character, or you do not add the same word again into your answer. If I use this D again, I will be able to find DB again, going diagonally in diagonal direction, but that is not allowed, because you have, either you go from this D to this B, or you go from this D to this B. You have to return it only once. So you have to also keep track how you can do. Instead of creating this answer as an array, create it as a set. So set will eventually add the words which are not previously added, right? So this is one thing that you can do. Next, coming on to the next position, starting with B. So I know there's a word starting with B. So what I can do, I can go in this direction. Let me just write this like this. I can go in right direction, downwards direction, diagonal direction. So first I will explore this, whichever way you are writing, you will explore the options. You found a C which is matching to the character at this position in one of the words. So wait, I'll stop right here. Why I will not proceed with this approach is because in this approach you are checking each cell and let's say there are n cross m cells. So you are doing this n cross m times for each word, not for each word. Basically you are you go, doing this backtracking thing for each of the cells, right? And let's say there are n cross m cells, so you are applying backtracking and total you have 8 directions. So this approach is not very good. Why? Because n cross m times you are at this cell, you have again let's say 8 options on average. Okay, then you have another cell, again you have 8 options. So as many cells you have 8 options. So 8 into 8 into as many times you have cells in your matrix, that is n cross m. So can you, this is n cross m times, right? So that is typically a to the power of n cross m, right? I can make this searching thing in a, I can reduce the time complexity of this searching thing. At least this 8 to the power, just tell me one thing, 8 to the power 1, 8 to the power 2, this n cross m, if I reduce this, a little bit improvement can be made, right? So just to improve this factor, let's do one thing. Instead of going in each cell and checking if a word is present or not, why not pick up words from your dictionary, right? And check if your board contains it. Clear? So obviously if you have a board like this, there may be many words and each word minimum, let's say if I take minimum also of one length of string, your board is going to be of length greater than the number of words in your dictionary, right? So let's try like this, that you go and check each word in the dictionary, apply DFS on each word if you are able to find it in the board. Let's iterate and check how we can do. So let me draw this again. You have DDBF. Let me write it. So this is your board, DDBF, or I had chosen another one. Okay, DDBF. Then you have EC, BC, and DC. Okay, so let's say this is your board and you know the words, those are BCD and DB. So fine. So what can I do? Let's start with this word. I start with, right now my word is BCD. So you want to check if you have BCD in your grid. So in your grid, this is 0, 1, 0, 1, 2, 3, 4. So which index you start with? You are trying at every index, whichever index you find B, you start your depth first DFS, or you can say backtracking, not backtracking. First you will recurse and then when you will backtrack, I'll tell you. So let's move into the grid. Start from 0, 0. How do we iterate? How do we traverse over a matrix of n cross m size? You know that using two for loops. So I start from 0, 0, 0, and I check if, because each position, each cell in your grid will contain only one character. So right now I am having, let's say, an index which starts from 0. Right now it is 0. It tells me that I'm checking for 0th index of this word, right? So I'm checking for B. Is this equal to B? No. So I move to the next one. Is it equal to B? Yes. No, it is not equal to B. No. Then I come at this position. It is equal to B. Okay, so now wait. Since I found one character matching, now I want to see if I can form the entire word. So the next position I can go from B are these positions. This, and do you see any other position? Yes, this and this also, but these I must have already, either I can mark them true or I can check also, doesn't, but to reduce the number of calls you can mark them also. So let's say if this is not true, I mark them, and that's how you can do it. Wait, coming to the next traversal, when I go to F and let's say there is this function which is taking your board. Let me write the parameters your function is taking. So you have this function called let me write it DFS. So this is the function which is having this board, correct? It is having the row index, j's index, and it is having the idx, the index for the string, and let's say it is also having the string s that tells which word you are checking for, and there is one loop which is already making a call to this DFS for this word right now. Now what I do, so what should be your base case condition? Your base case condition should be each time your idx is increasing, that is when you have found that word, right, that letter in your word. So when idx, this thing, don't worry if you don't understand right now, when we will get to the base case condition you will understand. If idx becomes equal to what, s dot length, not s dot length, the word that we are using which is s only, if that becomes s dot length, then you first should add it to your final answer. Let's say you have an array list or whatsoever, or you can do one thing, make this function of type boolean. So if you found a word, you return true. Let's say we are doing this thing right now. What other things you are doing? Then you are checking, forget about this base case condition, will come on this later on. First you are checking, this is your index 0, this is your letter. If you found this letter equal to the character you are checking for, right, so this contains b, so what you are going to do, you are going, when you found this match, you are going to check your I should be within the bounds, your j should be within the bounds. So let me write the bounds first. I should be greater than equal to 0. Next, your j should also be greater than equal to 0, because when you are calling for DFS, you can go in the backward direction also, you can go in the forward direction also. So whichever direction you go, you have to make sure that you are within the grid. So this is for this, and I should be less than n. Let's say n is grid dot size, j is less than m, that is number of columns, right? And also you are able to find that letter in your board. So board of which row you are talking about right now, I, column j. If board of ij is equal to what, s dot char at idx you can write, right? So s dot char at what, idx. If this becomes equal to index, then you have to do something, which is now you have to find out if you can form the entire word. So I have 8 options. I am representing with a, b, c, d, e, f, how many, 1 2 3 4 5 6, g, h. So these are your 8 options, which are you applying depth first search, that is you are recursively calling your function for what. When you found a b, the next position that you can go is right direction. So if you're going in right direction, what is the parameter that is changing? Your column is changing. So j becomes j plus 1. idx becomes idx plus 1, because now whichever character you will be checking for, it will add to the length of this string, the string that you are trying to form. Okay, earlier this tells me that this is a second character I am checking for. Fine. If it was first character earlier, now it will be second character. The next possibility is all the 8 directions. So one will be j plus 1, going to the next column, going to the next row will be I plus 1, and in all of these your idx will also be increased by 1. So this thing remains constant, means idx plus 1 will be same for all the DFS. And what all directions you are exploring, column increased, row increased, okay, and next what, diagonals, and above and all the behind directions and the above direction. So if you are one row above, I minus 1, idx plus 1, okay. So if you are one column behind, so that will be j minus 1, idx plus 1. idx plus 1 tells me the character, the which character I am checking for, okay. Next one will be your DFS for diagonals, which will be, let's say you are moving in which direction, I plus 1, that is your next. Let me show you. You are at this position, so when you go, this is your j plus 1, right, this is your I plus 1, this is your j minus 1, I minus 1, then this is what, this is your I plus 1, j plus 1, sorry, I minus 1, j plus 1. Similarly, this is I minus 1, j minus 1. Now this will be what, this is I plus 1, j minus 1, this is I plus 1 and j plus 1. Fine. So all these directions you're going to write. So now it will be I plus 1, j plus 1, I plus 1, j minus 1, and so on and so forth. 1, 2, 3, 4, I minus 1, j plus 1, I minus 1, j minus 1, and idx plus 1 will remain same for all, right? Okay, now what is the next thing that we have to do? Fine. So any of these directions, if when I move, so from B, whichever this, when I move at this direction, this will return me false. This should return me false because I cannot form a word which is present in dictionary if I choose this direction. Then I move to this direction, returns me false. Then I move to this direction, returns me true for finding C because C is present in B, C, D. Okay. Then from C, I again have these many options, but when you try to go to j plus 1, your index out of bounds will come, so you will not eventually go. So you have 1, 2, 3 options for here. Okay. Oh, and this F also. So if you move in this direction, F will return false, E will return false, B will return false, C will return false. So eventually this call will return false to B. Okay. So you have explored all the options for B, correct? Now when you have explored all the options for B, that means DFS function for when you made a call for B, right? This will return you false. Now you will check for the next position in your board. So this thing we are handling using a for loop, which is actually iterating over each word, and each word you are checking for character of that word in each of the positions in your grid, which I'll show you when we code, you'll understand it. Okay, fine. So the next position is F. For BCD, there is no letter F which starts it. Now IDX will be 0 again, right? So again for E, C, now you are back at this B. So B, for this B, IDX is 0 again. Okay. Now you move in this direction, you find a C. So your IDX also increased, and when you went to this direction, you have how many options? 1 and 2. So if you move to this direction, it will return you false because BCC is not the word you are checking for. When you move to this word, so this, when you move to this word, see, IDX was 0 here, IDX was 1 here, IDX becomes 2 here. Now from here you cannot go anywhere, and when you were trying to go, you were increasing your IDX also. So when your index becomes equal to string dot length, so string was BCD, where that means you must have found all the letters of that particular word. So you return true in that case. You got it? When are you returning true? See, rest of the things you are already handling in this if condition. You are checking for these conditions. Whenever you found a match, you are now making recursion calls for that match. And wait, before we make this recursion call, we are also doing one thing, which is for that letter in your board, so that we do not come at that letter again while we are applying DFS, correct? So you also simultaneously, when I found a B, I made that B as, let's say, you can mark it with any character. I'm marking it with asterisk, okay, 1 star. Then I moved to F. F was marked as star, but it returned me false. So when it returns me false, that means I am backtracking over that character. So whichever word I marked as star, I should make it back to what I marked it. So let me take some character. Temp is equal to what? That board of IJ, correct? And now board of IJ, mark it with B of IJ, mark it with some character, let's say asterisk. So when you are backtracking, let's say which statement will make you go at F, that is when you increase column by 1. So when you are at B, you make a call to this j plus 1, this line. Okay, so this line will increase your column by 1 and index by 1. Now you go make a call to DFS with I is equal what it was earlier, j plus 1. You check this condition, is IDX equal to string dot length? No. Then you check this condition, and when you check for board of IJ, okay, so this if returns you false. So when it returns you false, you have to ensure that this thing is false. We did not go into this, so it was not marked as asterisk, but so far my B is marked as asterisk. Okay, so okay, fine. So this returned you false, you came back to this. Then you move to E using this statement with I plus 1, IDX plus 1. So this, when you make a call to DFS again, this will also return you false because you will not be able to make this condition true. Okay, so then again you return false. So this false will be returned to which call? So this false will be returned to this function call, that is when I was at this index and I made a call to E. Now this returned me false. So basically the answer for B, this statement is also returned as false. This one also returned me false. Now I'm checking for next option, which is diagonally in this direction. So when I call at C, that is I am increasing my I also and J also. So I am basically executing F. Now let's see what F gives me. So you make a call to DFS with I, J as you have given. Both increased by 1. ID is also increased by 1. Okay, so you check, this is not true, but when you check, this statement becomes true. So when you make this true, your C will also be marked as asterisk. Now you make your DFS calls from C. So when you make all the all possible DFS calls, you will see that you will not be able to find a true from there, correct? Each of these calls will return you false. Why? Because this condition will fail. This condition will fail, correct? Fine. Because your IDX is pointing to D, but you will not be able to find a D from any of the DFS calls starting from C, correct? Okay, when you return a false to C, you have to make sure that C did not give you any answer. So, but you made it asterisk, so this should be returned back to what you changed it. So it should be made it back to C, so that I can know this C is returning me what? False. False to which call? To B. So I can know that B has explored all the options and none of the options is true. Neither this, nor this, nor this. So this I have to ensure, so that now this B is also made back to B and C was also made back to. Process of backtracking should be taken care when I have made all the calls. If these calls are not true, for sure I am making board of IJ back to what I changed it to, make it back to temp, correct? And then you return whatever answer you getting, that is A or B or C. That means or operation I am applying, which tells me if any of the operations is true, I will return a true, and so on and so forth. Fine. If you do not hit a true from here, finally for the function sake you are returning false. Okay, so that's how we are doing this question. So let me see if you guys have any doubts so far. So let's move to the code. So Rahul Singh, I think you are very bad at reading people. My task is to create videos here, not for the views, so that anyone who visits SD sheet can have a solution for the problem, right? Okay, so I think you are not interested in understanding the problem enough. Fine. Let me move to the code. Starting off, so this function, in this function, what we, let me just take it. So since I told you, I already discussed this thing that we want answer only once. I do not want to repeat my answers. So for that sake, I will take a set. Okay, so let me start with to store my answer. So set, which is typically a hash set. So set of string res equal new hash set, correct? Fine. So now I am iterating over each word in my dictionary. So for int, I equal to 0, I less than dictionary dot length I plus plus. Fine. Okay. So this, now for each word, since I told you that we are iterating over our board, for each character we are checking if I am able to find that word in my entire board. If there is a match, I go and apply DFS. If there is not a match, then I check for the next word. Okay, so for int, j equal to 0. Before that, let me write which word I am checking for. String word is equal to dictionary of I. Fine. So j is less than board length. Code might seem a little lengthy, but if you understood the logic, it's very easy. K is less than board 0 dot length. Fine. K plus plus. Now you are checking, you are making a call to your DFS function which takes this board. So board, it takes the row, it takes a column, then it takes a string. Okay, let me write it. It takes the word which I have written here. It takes a word, row, column, Then next thing that you can send is n and m, which is typically your board dot length. Okay, next is board 0 dot length. Okay, then this is the index idx which I'm passing. You will understand it when I write this DFS function. So if you find a true from here, what you're going to do, you're going to add that word to your res hash set which you created. Okay, so the word will be added, and then you try out for the next word in your dictionary, so on and so forth. Okay, the next thing what I'll do, I'll write it later on when we want to return the answer. Now let me create this boolean type of function DFS, public boolean DFS, which is taking your board, right? So it is your character, one second, character board. Let me pass it. Int string s, int I, int j, then you have int n, int m, and int idx, correct? Okay, let me check s, I, j, n, m. Fine. So what was your base case condition when you reach the end of your string that you are checking for? So if idx becomes equal to s dot length, okay, that means you can return true and you have found that word. Okay, next thing is you are checking for the edge cases, edges of your board, and what is the max extremes that I and j can go as rows and columns. Okay, so I should be greater than or equal to 0, j should be greater than or equal to 0, I should be less than board dot length, which I have taken as n, I should be less than n, j should be less than m. Next thing that you are checking is board of ij, right? That character should be equal to str.char at idx. Okay, fine. So next thing what I told you, that we have to mark that we have visited this character while we are making the recursion calls, so that we do not include it again into our answer, correct? So I am just keeping it in temp variable and changing the board ij to some character which is asterisk here. Okay, fine. Now you have how many options? You have 8 options. Let me write one. Let me just quickly take these options. Okay, boolean a equal dfs, right? So you are passing what? Board passing board si plus 1. Let's take j plus 1. Next is n remains same, m remains same, idx is increased by 1 each time, right? So let me just copy paste it and I'll change the values 8 times. How many times is it? 1, 2, 3, 4, 5, 6, 7, 8. Fine. So j plus 1. Next I can do is I plus 1. Then I can I minus 1. Then I can do j minus 1, I plus 1, j plus 1, I plus 1, j minus 1. Fine. I minus 1, j plus 1, and then I have I minus 1 and j minus 1, right? And for each of the cases you have idx. Finally, when you have made all the recursion calls, when you are backtracking, you have to make sure that board of ij is back to the temp variable that you stored with, correct? And then you should return a. Also, let me change these values. A or B or C or D or E or F or G or H. Fine. So this is what you are trying to do. And then if you do not hit a true from any of these conditions, you return a false. Now next thing what I'm doing here is, when you come out of this loop, you want to return answer as a string array. So I have to take all the values from set to a string array, which I'm creating now. String arr new string, and the length should be set dot size. Okay, set dot size. It is res dot size. Fine. Next thing, let me take int I, which I'll use as a variable, which will be increasing while I'm adding to my answer. So arr for string, let's say element belonging to my set res, I am adding to my arr of and incrementing the count with element. Okay, and then finally you return arr. Let's see if this passes. Board of ij, ij plus 1 and j, str, this should be s. Let's check now. It returned false. Let me see what is the issue. So we are making a dictionary. Okay, so this is not ij, this should be your j and k. J, k. Let's check now. Fine. So that's your problem, which is submitted now. So if you have any doubts, you can ask me, and that is all for today. Then I'll just come upon its time complexity as well. Sure. So I'll come back to the approach. So what we have done in this question is, see, this question is a very good problem of backtracking. What we are doing, see, if I think, let me just show you the code. See guys, I have a dictionary, right? Instead of going at each position of your grid and checking if I can find a word from that position, I'm doing something else, that is just check for words in the dictionary. Okay, let me write it here. Now just listen to this approach and you will understand it. So for each word in dictionary, okay, you are iterating over each position in your grid, okay, whichever grid you have. So your task is to find if grid contains word. If this returns you true, then let's say I have a set as a result, you will add that word into a result array or whatever you have taken. Okay, and if your grid does not contain this word, you check for the next word. So each word I am checking if my grid contains it. If it contains, I will add it to my final answer. If it does not, then I will go to the next word. Now the task is to make a call and execute the function. How to check if your grid contains? So grid contains, let's say, if it contains this word, how can I check it? So to check this, I am using this concept of backtracking. How am I using this concept? Now you know that I have a grid, okay, and it has certain characters also. So for each character, let's say I am checking for word geeks, and this is my grid given to me. The board is GIZ, UEK and QSE. Fine. And right now I am checking for this word geeks. So what will this function do? This function will check the first position. You are checking for which position. Since you have used this loop, if you see, I have used this loop which iterates over each row and column in your board, and for whichever position you are checking, you are passing that position as your ij, that is the row and column for which you are traversing or making this recursion call. Then you will check if that ij contains, your board of ij contains s.char idx. So right now my word is geeks, okay, so I'm telling you this test case. My word is geeks and idx is 0. That tells me that I'm checking for the 0th character in this word. Then in my board I check for j and k, which is 0, 0 right now. If it contains G, then I will check. Since it told me, so this character is G, so this tells me that there is a possibility to find a word which is geeks. So from G, I will use depth first search, or not DFS, you can say that I am making recursion calls in which directions. I am making recursion calls in 8 directions, which are, in this case, it will be reduced because you cannot go here, you cannot go, because this is 0, 0. But I will explore all the possible options. So when I went at this position, so this position I can go to, that is I plus, this is j plus 1. That means I'm executing this statement. So when I'm executing this statement, this is making a recursion call to your function again. So this function has now updated its index I, its index j, and this index idx. So now your ij is what? Your j is increased by 1. Right now you are at this position. So again you will make a check using this condition. If your, first of all, you will check if your index are not out of bounds. Then you will check if that board ij is equal to s.char idx. So your s was geeks and index this time is 1. So that means you are trying to match a e with the character in your board. Let's check. So I is not equal to e. Since it is, this condition fails, so this if is failed, so I return false for this. Now this false returns to which position? So this false is returned to the function which made a call to I. So this false will be returned to G. That tells me that out of these, my A returns me false to G, right? Now I will try another option which is going down. So this is also not equal to E. Then I will try this option which is going diagonally. This returns me E. Now I will repeat the same process for E. Eventually I will find E from here also. Now next is K, I'll find a K. Then next is S, I'll find a S. When I try to move from S, I will see that I have already found a word which I was asking for in the dictionary. So that means my index must be equal to length of this word. So this is the base condition I have used. So when index becomes equal to the length of that string that you are checking for, that means you have found each character of that string. So you return a true. And when you return a true, this true will be returned to this DFS function, correct? And when you return a true for this DFS function, you add that word into your final res, which is a hash set here. And then I'm converting that hash set into a string array because I have to return the answer into a string array form, right? So I hope this is clear to you now. If you still have any doubts, you can ask me. Talking about its time complexity. So using, if you see this loop, where is it? Okay. So if you see this loop, we are iterating over each word. So let's say the length of your dictionary is L. Okay. Length of your dictionary is L. And for each length of your word, you are traversing over the each row and column in your dictionary, in your grid, right? So let's say this is N, this is M. N. This is N and this is M. So L into N into M is very clear, right? Now what is, in what time complexity am I doing this task of DFS? So if you see, I am doing this L into N into M, L into N into M, and this thing I am doing how many times? So L into N into M is done. Now I have to add the time complexity that my depth first search is taking. So how much time is this DFS taking? So if you see, my depth first search for each character, for each position in this, right, I have how many options? I have 8 options to explore. So one character, let's say G, is taking 8 times, okay, or 8 thing, I have 8 options to explore. Same goes for I have 8 options to explore. Same goes for Z, I have 8 options to explore. Basically, when you are applying a depth first search, for each character you have 8 directions to explore. So 8 into 8 into 8, as many times, how many times you have this 8, as many times you have that word that you are checking for. So 8 into 8 into 8 to the power of something, which will typically be the length of this word that you are checking for, correct? So this exponentially goes to the time complexity of n cross m, you can say, which is not a very good time complexity although, and this thing can be improved using tries. Okay, so it is typically exponential, and so we can improve it using try. But since this is a problem of backtracking, the concept of backtracking becomes really clear when you solve this question. Since, see, they are also not expecting you to solve it in very less time complexity, so this works in this case. Okay, so see, backtracking, who told that backtracking, in backtracking we cannot modify the board? We are modifying the board and also changing it when we are backtracking. So what we are doing, what do you understand by backtracking? Backtracking means which, there is some position which I came, and that position I did some operations. Okay, this is some position. Now from this position I went to further next position, let's say position plus 1. From there I went to position plus 2. Backtracking typically means that when you have made the recursion calls and you are going back, now you are trying to remove the call stacks from your, that these call stacks need to be removed, right? But you are doing some operations while you're removing them. So you return some answer to the previous call. That's how your recursion works. While you are doing so, you are modifying the board when you were making the recursion calls, and when you are backtracking you are remodifying them to the original value. That is, when you were at G, you made it as asterisk. When you were at E, you made it as asterisk. But when you were backtracking from all these positions, you were making these asterisk back to what they were originally, so that your board is retained back to in its original forms, so that my answer is not altered when I try for the next characters. You got it? That is what is happening while we are backtracking this. Let me know if you still have any doubts. So this is what we are doing while we are backtracking our board, or backtracking the recursion calls. Fine. So if you still have any doubts, let me know. And these questions we have solved previously also in our SDE sheet. So if you have already attempted those problems, this shouldn't be an issue to understand. But I expect that's a prerequisite, that you understand the basics of backtracking. Otherwise, this question can be a little difficult to understand that what is happening. It is very simple. We have 8 options to explore. We are exploring each of these options. Whichever returns me true, I take that into my answer. Otherwise, that, let's say I am at this position, this returns me false, I come back to the function call which made a call, explore the other option for it until it returns me true. So if this also does not return me true, I check for the next option. If this also doesn't return me true, I check, so on and so forth. That's what you are doing. Okay, how many times? I think you can go to the video again, because I can't be repeating the same thing for twice or thrice. You can check, and when this video is over, when I'm done with the stream, you can replay the video and you will understand it again. That's all. So do you still want me to explain it, or would you prefer to go back to video and understand? Thank you. Because same thing I have already iterated with using many examples also. So once you go to the video from the beginning, you will be very clear with what I'm discussing. Okay. So let's wrap it up then. Thank you everyone. See you all in the next lecture.